So what we are going to discuss regarding KB-270, and in KB-270 what was our question? Regarding coefficients, right? So how many coefficients are here? It is having A0 to A6 means total 7. Now the question was from where these coefficients have come. When you have a, let's say how many channels are there in KB-270?
50.
But single channel can have
4 compositions.
4 compositions, right? 4 compositions. Now, out of, let us take one composition, right? Now, in the one composition, let us assume it is as a fat or oil or whatever it is, right? Now, in this composition, you require minimum how many samples to be tested? 9 samples are required to be tested, right? Then and then it can do a calibration on the machine. Agree? Okay. Now, when you take sample number 1, 2 ones. For each sample, you are getting absorbance, and absorbance was written in another variables. They have used another variable for absorbance, that is x1 to x6, right? Can you see the value of x1 to x6?
Yes.
Can you see the value of x1 to x6? Right? So you can see the values of x1, x2 up to x6 for each
Sample.
not composites. For each samples. Sample is within composition. This is composition. And within this composition there are 9 samples. For each sample you have a 6 absorbance band. Right? Now we don't have a, as of now, you cannot directly correlate this with this as of now. See, there is a relation, but we cannot say that there is a you can directly correlate. We don't have a right now direct correlation in terms of some mathematical formula or something like that. It's not like that, right? Then what is the relation? These are 6 coefficient and these are 7 coefficients. So you cannot establish a relation because both are having a different values. Now the question is, what is the relation? What is this A0 to A6? This is known to you. Now for each samples you will be having this absorbance value. So ultimately it will be represented in terms of waveform. If you see, I don't know, I have not seen the wave software, but it may be in the form of waveform.
Spectra.
Am I right or wrong? Right? So for each this thing, it will calculate some value, absolute value. For each this sample, it will calculate some absolute value. I'll say that it is having value 1 of this sample. Value 1 means value of fat for this sample. Value 1 means what? Value of fat for this sample, which is being calculated by instrument using this absorbance band, and that value is V1. Similarly, it will calculate for sample 2 using another this absorbance value, and that value is, I'll say, V2. Similarly, it will calculate how many values? V9. It will calculate V9. So how many values are there? 9 values of actual fat. But it is calculated by instrument. So we cannot say that it is correct. It may not be. It may not be. You're getting my point or not? So this V1, V2 up to V9 are, you can say that, actual values. These are called as a actual value, right? Now the problem starts over here. Actually, not a problem, but this is the actual step that from where this A0 to A6 have come, right? So you have V1 to V9. So let us say I'll represent, this is X, this is Y axis, V1 to V9 in a XY plane. So let's say we have a V1, V2, V3, V4, 5, 6, 7, 8 and 9, whatever it is. Let's say V1, 2, 3, 4, 5, 6, 7, 8 and 9. I'm just assuming, right? Now actually, if I'll connect all these points, and this is the representation. If I'll connect all these points, now is it linear? Is it linear?
No.
It's not linear, right? So I cannot use this equation y is equal to mx plus c. I cannot use, right? So ultimately what I have to do? Ultimately I have to use multiple coefficients, because it's a non-linear thing. If it is linear, it is a straight one, whatever it is, likewise whatever, right? But this is non-linear, so I have to use multiple coefficient. Now the question arises, how many coefficients should I use? So that is not in our hand. How many coefficients should I use? That is not in our hand. It is already fixed in the instrument that they will use A0, A1 up to A6. That means total 7 coefficients they will use. Total 7 coefficients they will use. That means what? Using this 7 coefficient, you can represent this plot. Using these 7 coefficients, you can represent this plot. Are you getting my point or not? Right? Now, this plot is being represented by these 7 coefficients. Is it clear?
Yes.
Is there any confusion?
No.
Clear? Huh? Okay. Now, what to do with this? Why do we have this? Why the instrument has done this? Now, okay, when will you get this 7 coefficient? When will you get this 7 coefficient? When you take all 9 sample minimum, then and then you will have this 7 coefficient. Otherwise, you will not get 7 coefficients. They have mentioned, they have restricted that you have to take 9 samples, then and then you will get 7 coefficients. Otherwise, you cannot have a 7 coefficients. I mean, they will not calculate this plot. I am not saying that you cannot.
Minimum 9 is required.
So that is their constraint, instrument's constraint. It's not like you cannot do. You can do with 2 points also, but it is the instrument's constraint. Right? So we have to work according to the constraint of the instrument. So getting my point or not?
Yes.
Now, what to do with this 9 coefficient? Because this 9 coefficient we have received after 9 samples. Okay, so we have this initial 7 coefficient. So I will use a word these as the initial coefficients. I will say that it's a initial coefficients, right? Now what do we require to tell to the machine? What do we require to tell to the machine? These are actual value. What is our objective?
Standard value.
You have to tell the machine that now you have to fix the standard value. Okay, so I'll represent standard value as a cross, right? Do we have another color pen? ચાલે છે?
બોર્ડ પર ચાલે.
No. So now this is, I'll say that actual value. Now let's say we have another values somewhat here. There is something like that, right? So I can also plot this. This is a reference value. This is actual value given by the instrument, right? Now what is our objective? What is our objective? This value must match with this standard value. That is our objective. We have to do actually mathematical calculations so that this should happen. But that is also not our headache. Who does on our behalf?
Machine.
Machine is doing. So machine is smarter, right? It is smart enough to do this calculation. We don't have to bother about it. Clear? Now what machine will do? Machine is having this as a reference, 6, 7 coefficient, right? Now machine will adjust this 7 coefficient and it will modify in such a way that this blue plot will try to match with this green one. So it will try to align with this. It will try to align with this. Clear? And that's why these values are changing once you apply calibration. These values are changing once you apply calibration. Is it clear? Why these values are changing? Because you are applying a calibration, that's why it is changing. Otherwise it won't change. Clear? Okay. Now what another point which we have not discussed in the last discussion, that is a coefficient of or correlation coefficient. Correlation coefficient. Correlation coefficient. This is very important parameter, and which is there in calibration. Without this coefficient of correlation, you cannot say that how accurate the calibration was done. How accurate calibration was done. So, what was our objective? This value should match with this. So, how well this actual value is aligned with the reference value will tell you will that information will be given by the coefficient of correlation. In a nutshell, that information will be given by the coefficient of correlation or correlation coefficient, whatever you want to say, right? Some people may use a word R square. Some people may use a word R square. Now it is having value in between 0 to 1. It is having value between 0 to 1, right? 0 means not aligned. 1 means it is 100% matching. So more nearer to 1, better the calibration. More nearer to 1, better the calibration. Clear? So if this curve exactly matches with the green one, blue one exactly matches with the green one, that means it's the best calibration you did. It's a best calibration you did. Clear? Is there any confusion?
No.
So why you are confusing since last 2 months? Clear? If you have any query, any confusion, then let me know. So what we are going to discuss regarding KB-270, and in KB-270 what was our question?
Coefficient.
Regarding coefficients, right? So how many coefficients are here? It is having A0 to
A6.
A6 means total
Seven.
7. Now the question was from where these coefficients have come and how to use this coefficient. Right? This was the fundamental question which I have asked since last 2 months. And you are reading this manual again and again. How many times you have read, I don't know. And still today you are confused that from where it has come. Right? So understand, not read. Read and interpret. Okay, so see, when you have a, let's say how many channels are there in KB-270?
50.
But single channel can have
4 compositions.
4 compositions, right? 4 compositions. Now, out of, let us take one composition, right? Now, in the one composition, let us assume it is as a fat or oil or whatever it is, right? Now, in this composition, you require minimum how many samples to be tested? 9 samples are required to be tested, right? Then and then it can do a calibration on the machine. Agree? Okay. Now, when you take sample number 1,